You've seen the fireworks. Now let's get down to some real explosions. Welcome to Explosive Chemistry 101. I'm your instructor. I know you came here to learn how to blow stuff up, but before we get to that, we need to cover some basic chemistry. So grab your goggles and lab coats. It's gonna be a great semester. We'll start with the basics. What actually causes a detonation? Well, the short answer is a chain reaction. When a substance undergoes rapid exothermic reaction, the heat generated by the reaction causes the gas molecules to move extremely fast. The increased pressure from those fast-moving molecules causes even more of the substance to decompose, releasing even more heat and causing even more pressure. This creates a self-sustaining reaction that rapidly propagates through the material, releasing a tremendous amount of energy all at once. And that's what we call an explosion. So what's the best way to initiate this chain reaction? With a little something we like to call O-N-I-T-R-E-G-L-Y-C-E-R-I-N-E. Okay, class, I know that was a lot to take in. Let's review. Nitroglycerin is a highly explosive organic compound and is one of the earliest known explosives. In fact, it was discovered accidentally in 1847 by a Swedish chemist. But don't worry, he was actually trying to synthesize a more stable form of gunpowder. And although he didn't succeed in creating a more stable form of gunpowder, he did create a very unstable form of gunpowder. So how exactly do you cause such an explosion? Well, nitroglycerin is a liquid at room temperature and is colorless and almost odorless. However, it is extremely sensitive to shock and friction, so much so that even the slightest jostle could cause it to detonate. This made transportation and handling extremely dangerous. In fact, there were many accidents during this time period that resulted in serious injury or even death. But we're not done with nitroglycerin yet, so let's move on to our next lesson. In order to make handling and transportation safer, chemists began to mix nitroglycerin with an absorbent material to form a jelly-like substance. This made it easier to handle and transport, and it also made it less sensitive to shock. This new form of nitroglycerin was called dynamite, and it quickly became the explosive of choice for construction and mining companies. But some chemists weren't satisfied with dynamite. They wanted to create something even more powerful. Enter TNT, or trinitrotoluene. TNT was first synthesized in 1864 and it was immediately recognized as a powerful explosive. It is much more stable than nitroglycerin, which made it easier to handle and store. Plus it packs about twice the punch of nitroglycerin. But there's more to explosives than just the chemical composition. The shape and construction of an explosive device can also play a major role in its power and effectiveness. That's why we offer a variety of different shape charges, each designed to maximize the destructive potential of the explosive. From the classic cylindrical shape of a stick of dynamite to the cone-shaped charges used in demolition, each shape has its own unique properties and uses. So if you want to learn more about the nitty-gritty of detonation, stay tuned for more lessons. Next time we'll explore the fascinating science of detonation velocities and detonation products. Until then, review your notes and stay safe in the lab. I'll see you next time.